Hello. Okay. So these functions give students problems when applying the definition of the derivative. So I thought, maybe I should do one. So let's do it. Right? So once again, look, we're just using one idea. And that is this one. Limit h approaches 0 of f of x plus h minus f of x over h. If you're not sure why this is what it is, please check out previous videos. Okay. So just like some other stuff that we've done before, this is given. Given. It is the function you see on the screen already. We need to find this. And h is just h. This is a horrible looking h. That's an h. There we go. Okay. So let's find f of x plus h. And once again, all we got to do is replace x with x plus h everywhere. So here we go. 3x plus 2. Instead of 3x plus 2, it's going to be 3x plus h plus 2. Over, and instead of x plus 1, it's going to be x plus h plus 1. There's x plus h. Done. Okay? Now let's plug it into our slope formula, our dy dx. There we go. All the different notations. Let's plug it in. Limit h approaches 0, f of x plus h. Okay? I've got f of x plus h here already. I'm going to do a little bit of algebra. I'm going to go ahead and distribute to 3. So I'm going to have 3x plus 3h plus 2 over x plus h plus 1. There's f of x plus h minus f of x, which is given. 3x plus 2 over x plus 1. Be careful with your grouping symbols. You're subtracting the whole thing, so put the thing in parentheses. People make that mistake all the time. Don't make that mistake. Okay. Divided by h now. All right. So, nasty algebra time, yeah? So in the numerator, we have two fractions with different denominators. One denominator is x plus 1, and the other one is x plus h plus 1. These denominators, while they look similar, are in fact completely different. So we need to write down the least common denominator. And good thing we did this in pre-cal, right? So x plus 1 times the other one. X plus h plus 1. There's our least common denominator. So in the first fraction, what factor is missing from the common denominator? It's x plus 1. So we're going to... Oops, I forgot to change the color back. No big deal. We like colorful videos, don't we? Okay. So I'm writing that down. And this already has x plus h plus 1. We're missing the x plus 1 bit. Okay, so we're going to put the x plus 1 bit in there. Like that. Minus. Same reasoning. This one has x plus 1. It's missing x plus h plus 1. Minus 3x plus 2 times x plus h plus 1 over x plus 1, x plus h plus 1. So we got a lot of nastiness going on here. But we are not worried. We will not be intimidated by long expressions. Okay? All that over h. Okay. So now, honestly, look, you just do it, okay? You do the operations. Okay, so we have a lot of multiplication to perform. I'm going to distribute. Well, I'm going to see if there's anything I can factor, and it doesn't look like it. So I'm going to distribute, okay? So I'm going to do 3x times x, 3x times 1, and then I'm going to do 3h times x, 3h times 1, and then I'm going to do the same thing with the 2, 2x, and then 2 times 1. So that's what I'm going to do. I'm going to keep the denominators the same. I'm going to do the same thing to the other term here. So, let's keep the colors going, right? Let's just see how many colors we can use, right? So here we are. Limit h approaches 0. And just for funsies, change the color. 3x times x. 3x times x is 3x squared. 3x times 1, and because the exponent is different, we'll do plus 3x. Okay, so that term's done. Moving on to 3h. 3h times x, that's a different type of term. So let's use a different color. Plus 3xh. So 3 different colors, 3 different types of terms. I'm trying to emphasize that these are not like terms. 3h times 1, just 3h, and again, that's a different type of term again. Okay, and then we have 2 times x, and that's going to be the same as, oh man, can I reliably get that color back? Oh man, I don't know. Let's see. That looks pretty close. 2 times x. Oh, that's not close at all. Whoa, okay. Let me erase. I had good intentions. Maybe this one. That's pretty close. We like that. Good. Okay. 2x. And then 2 times 1. Believe it or not, that's a different type of term again. 2 times 1. It's 2. Okay. All right. Moving on. 3x times x. That's 3x squared. Okay. And it's being subtracted. 3x times x is positive 3x, but with a minus. So minus 3x squared. Then we're going to do 3x times h. So that's going to be a blue term with a minus. These are all going to be minus, thankfully. That's make it a little simpler. 3xh. 3x times 1 is going to be 3x. With a minus. Okay, so that term's done. Now the 2. So 2 times x plus 2x. But then it's being subtracted, right? So minus 2x. 2 times h. It'll be 2h. 2 times h. 2h with a minus. All going to be minus. Minus. 2 times 1. 2 minus. All right, over. Oh my goodness. Over h. Well, no, I'm sorry. Woo! The h will be down there, but not yet. X plus 1. X plus h plus 1. Then all of that over h. And remember, h is over 1 itself, right? So we essentially have 2 fractions being divided. Okay, good. So now, look at the colors, everybody. Okay. Okay, so let's use this color all the way. Like terms. Yeah, look, 3x squared minus 3x squared. Yellows cancel. Plus 3x plus 2x minus 3x minus 2x. So look, boom, 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 boom. Yeah. Plus 3xh minus 3xh plus 3h Okay, we have plus 3h minus 2h. Check it out. Doesn't cancel, but we got 3h minus 2h. So let's sort of remember that that's going to be h when we combine these two. Okay. What else do we got? Plus 2 minus 2. Aha. Anything else that I didn't take into account? I think that's it. Done, done, done. That's H. Done, 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 done. Okay. All right. Good. Okay. So that simplifies tremendously. Limit as h approaches 0. And what's going to be remaining on the numerator? Just h. Okay. This denominator, x plus 1, x plus h plus 1, and then times h. Okay, I'm playing the complex fraction game, from pre-cal or from algebra. This one here, right? You students like to say keep, change, flip. Keep, change, flip. The idea is that if you are dividing by a number, that's the same thing as multiplying by its reciprocal. In other words, if I divide by 2, it's the same thing as multiplying by 1/2. Okay, so flip the bottom one and multiply. So if I flip h over 1, I get 1 over h. H times 1 is h, and then I just have multiplication by h in the bottom. Okay? All right, so now look at what happens, right? Terms not involving h in the top go away. And check it out. H over h is 1. Limit h approaches 0. Please remember, everybody, that this is h times 1. I've seen so many students cancel something on top and then they go and make the denominator the numerator. Yeah, don't do that. The denominator is still the denominator. H over h is 1. That's the point, right? H over h is 1. It doesn't disappear. Okay. 1 over x plus 1, x plus h plus 1. Okay, now, if I attempt to plug in 0 for h, everything's good because I got rid of this h and I got rid of this h. So if I plug that in, I get 1 over x plus 1 times x plus 0 plus 1, which is 1 over x plus 1 times x plus 1, which of course is 1 over x plus 1 squared. Okay? And I will be honest, I actually didn't expect this result. And very quickly, I'm just going to check myself here and make sure that that's right. So f of x, woo, I used a lot of space. F of x was 3x plus 2 over x plus 1. And there's a rule we're going to learn later called the quotient rule. And basically what you do is you take the bottom, multiply by the derivative of the top. The derivative of 3x plus 2 is 3, minus the top times the derivative of the bottom. The derivative of x plus 1 is 1, over the bottom squared. I just want to make sure that this actually comes out to what we got. So I can distribute the 3. I get 3x plus 3 minus 3x minus 2 over x plus 1 squared. And that goes away. 3 minus 2 is 1. Oh, so good. That works out. Pretty cool. All right. Very nice. Yeah, so that works. And yeah, that's how you do it. You do it the exact same way we do other problems, except, since it's a fraction, you got a little bit more algebra to do. But the goal is the same. Get rid of the h on the bottom. Use the continuous function limit theorem. Plug in 0 for h. Get your result. And there's your derivative. Okay. All right. I will see you in the next one.